Hi, everyone. Welcome to another session of Big Data Boutique's Ask Me Anything. Today, I'm happy to have some Starburst people with us to talk about Presto. So I'll let them introduce themselves, but Starburst are the vendor or the company behind Presto. They're offering pretty much everything there is to know about Presto, including training. One session like that happens even in a couple of hours. They offer an enterprise version of Presto and obviously also all the knowledge around Presto, including cost optimizations and how to actually deploy that and connect correctly to any data sources and so on and so forth. So just a couple of words before we start, reminding you who we are. We are Big Data Boutique. We are working with Starburst. We are actually partners with Starburst. We are representing them and helping customers succeed in big data projects in general, and also with Presto and Starburst Presto in particular. We're doing a lot of projects around those areas, including Apache Spark, Kafka, Elasticsearch, and obviously clouds and Kubernetes. And today our focus is on Presto, which can help you do a lot of things from query big data on-call data storages like HDFS and S3, and also do query federation and join various data sources in a single SQL query, and that is what we're going to be talking about today. So when we will be discussing connectors today, just a short, small reminder that we do have a high-performance Elasticsearch connector, which we provide as part of the Starburst license package that we do provide. We added the link here, and it will be available in the video description later. We also are holding a hands-on workshop on August 17th. Again, attached is the link here, down here. And in that workshop, hands-on workshop, we'll have a couple of hours hands-on training on Presto. So without further ado, I'll pass this session, I'll pass the stick to Randy and Austin from Starburst. Hi, guys.
Hey, thanks so much for having us, Itamar. We really appreciate it.
Yeah, I'm very happy to have you. So before I give you the ability to share your slides and everything you prepared for us today, if you can tell us a bit about yourself and who you are and your job in Starburst, and just a small mention that whatever questions you have, Randy and Austin are about to give a short presentation and then are basically here to answer any questions that you may have. We will be monitoring both the YouTube chat over here, and we've added a picture of how it looks like in case you're new to it. And you can also ping us on Twitter or email, and we'll be available to answer all of those questions. So Randy, the floor is yours.
Yeah, thank you very much. And thanks for having us. A little bit about me, as you said before, which might help kind of give a little bit of background. I spent 20 years as an infrastructure architect, actually, before I jumped over to the vendor side of the house. And among my jobs was not only designing systems, but dealing with an awful lot of different data sources. Actually, I spent about 10 years or a little over 10 years at Abbott Laboratories, and we had something like 16,000 servers. So I was used to very large scale IT, and very often we had to deal with an awful lot of different data sources in order to even answer questions about our infrastructure, let alone what we were dealing with all of our business units and the kind of work we did at Abbott, which was, of course, in the life sciences area. So as I speak about this, I prepared a really short 15-minute presentation that talks about where Starburst Presto fits into the world and really can walk you through how it fits in, how it's a little bit distinct from ETL tools and other different areas that you might see. And feel free to ask questions along the way in the feed. We'll leave a huge chunk of time available for back and forth. It's one of my favorite things to do. I've done a lot of traveling around, going to meetups, which of course we're not doing lately, but looking forward to doing that again. And I'm really glad that we can do this online. For now, what we found as we've talked to very many different companies that are dealing with data issues is that there's really three data personas, or three groups of data personas is probably a better way to put it. It usually starts with a business question that are asked by people who are not really is clear about how to answer the question using data. They don't know SQL. They may not even know how to use some of the SQL tools that allow you to drag and drop, but their questions are more business related, like how much inventory should I buy based on prior sales? And they usually turn to the data analysts or data scientists who need access to the data sources to answer a question like that. The data team creates ETL jobs and grants access. And if you're like the Abbott bureaucracy is the best way to put it that I was at, it was under a lot of regulatory approvals for everything you do. It actually can take weeks or months in large enterprises. In smaller companies, naturally, sometimes your data analysts are squished into the data team and are doing both so that they can provide access a little more quickly. That still means that you have to deal with the ETL issues. Then you can finally provide reports. And of course, usually they've forgotten the question because the business has moved on. So the idea is to shorten this cycle that we see over and over and over again in the world to deal with it. And so there's really three methods that I've used to grant data access throughout my history. One is to use tools. And what you can do is give database access strings for all the data stores and just let the tools like your BI tools, such as Looker, for example, or Tableau, or things like Spark, to be able to merge the data in memory so that it can deal with it. You could use ETL tools to dump all the data into one place so that you can analyze it, or you can go with a federated access method. So that means you're using an abstraction layer to grant a single point of access to the data in order to get it. And I'm just going to have a really short discussion about each of these. Because I like alliteration, I actually just used S's for this one, and then the next one are D's. So for this one, we see a lot of security issues in that you have to handle security for each data store for the tools, because each data store is feeding data in. You really don't have a centralized place to handle it. You often have a scalability issue in that those tools are not meant to handle high concurrency. So it's fine if you have a handful of users, no problem. But once you start to get to 10, 15, 20 users, you really start to have some issues along those lines. The standards are challenging in that they often have different access methods in each of the data sources, and you can't always merge data from different data sources because there's different formats. There's sometimes different versions of query methods, so you don't always have SQL, which is nice and simple. You have other methods to do it. And of course, you have to deal with all the strings. So each data analyst gets their source connection strings and credentials for each data source. So it's a little bit challenging to manage. Another way to handle it, of course, is to bring everything to one place. And that handles some of the issues. You only have one connection string, but it's a little difficult. In the main data warehouse that I had at Abbott Laboratories just for infrastructure, when I was done and I had created a chart with everything, we had 25 different data sources. So this is things like information on our routers, information on our servers, information on the backup systems. All of these things sometimes needed to be merged together into multiple queries. And so in order to do that, you actually have duplicated sources. And because of the duplication, you have another problem in that it's delayed, in that it's on a schedule. I had my scheduled jobs fail once, and I had to actually add a lot more monitoring to those because my automated processes that were making sure that, let's say, whenever you added a server, that it was automatically getting backed up in this case, it was working on stale data and didn't keep up. And that became a real issue. So not only is the fact that it's on a schedule an issue and that it's usually as of 2 o'clock in the morning, but if that job fails, your data is also out of date and has a problem. And of course, the data warehouse is usually deficient. No matter how many data sources I added, once I had 20, there was a 21st that was needed. And very often that 21st was even messier than the last one, in that I would have to write a regular expression so that it was parsable into some columnar format so that I can actually query it in the first place, and had to deal with that. So the architecture looks a lot like this when you have a data warehouse, where you're putting something in the middle. You have some data sources that are out of its orbit, and the rest are pumping data in, any one of which could fail or even may need to be modified as your data sources change. So the federated access method, which is the one that Starburst Presto uses, makes it a little simpler to do this. And I really wish I had had this tool when I was working in that job. You provide just one database connection string for users to get a catalog with all of the data sources, and you query it using ANSI SQL. It normalizes it no matter what the underlying data structure is. Let's say it's Kafka, which is queryable, but it's queryable using something called KSQL. You really want to merge it with other SQL data sources. You can either pull the data in to the data warehouse we talked about before, or you can actually just have the federated access method normalize it so that you can do the queries. And then this allows you to add new data sources quickly and easily via a configuration string rather than an ETL. And so what it ends up helping solve when you start using this in your toolbox with all of the three methods is that you can suddenly add data sources much more quickly. You can access dissimilar data sources. You can get the latest data rather than waiting an ETL job to run. You provide, we talked about this, you provide uniform ANSI SQL access, because each one of these is slightly different. For those of you who have probably dug into this, you've run into these particular issues. And of course, it's very highly concurrent. And part of the reason why this is the case is that the architecture of this system has worker nodes. And the worker nodes can actually scale out depending on how many users you have at this top layer. Your middle layer can have as much compute as you need it, which is basically scaled separately than the storage, which is a nice challenge. And then you can access all of the data sources. Any of these workers have the ability to get to all of these different ones. So you can kind of think of Presto as a distributed SQL engine that provides a scalable, federated single point of access to the data. That's how it works distinct from the others. And when you start doing things this way, you end up getting quicker answers for the business, and they're thrilled with that. The data analysts have a much easier job because they have a single connection string. And once you do that, they end up seeing a catalog that has all of your data sources. And the DBAs and the data team who have to deal with the actual data sources, if you're in a large enough company, this is a separate role. They don't have to write an ETL, they just actually grab a connection string. And one of the things that I have on my computer that I can show, if I drag this over here, here's a properties file, an actual properties file from Presto. As you can see, we just have a connector name. In this case, the connector name is not the name of what you see in the catalog. That's actually the name of the file. So they would see this as the customer database dash MySQL. That's customer MySQL. It's actually using the MySQL connector, meaning I'm connecting to a MySQL data source. The connection URL that you can see right here is the same connection string that you're giving to users to get to it from their tool. And of course, we have the user and password, which in our enterprise version, you can keep this out of a text file and keep it in a vault, just the way you would expect to do that kind of thing. So adding new data sources is just creating a bunch of these little files and ingesting it into the system. And once you can do that, the nice thing is there's a lot of different connectors. So each of these various types of backends are available for you. And it's interesting because sometimes I talk to people and I actually see them making a slide that has all of these different logos at the bottom. The truth is it's not a logo, it's a data source. So where I dealt with this at Abbott Laboratories, we had multiple Oracle data sources and a bunch of MS SQL servers that were the backend for some of our infrastructure tools in this particular case, for this particular backend. And so what you'll often have is 2 or 3 or 4 of these, maybe one of these. You might have one big data warehouse of one of these flavors, and usually a data lake or two. The interesting thing that we found as we deal with customers is that a lot of them have data lakes because the storage is so much cheaper than paying for a license for a very big SQL server of some sort. And they're happy to have the data there. They just want to continue to query it as if it's a SQL backend. This is also true of some of these NoSQL databases that nevertheless can be queried as a SQL data source and put together for that. And we even have a lot of other things. It's surprising to me how many people are not only using Kafka, but I talked to one company when I did one of these talks just a few weeks ago, where they actually were keeping data in Kafka as if it were a database. That's not necessarily the best architectural choice. As I mentioned, I was an architect. I would never advise somebody to do that, but they needed to have access to the Kafka data. And Kinesis, of course, is an Amazon flavor of Kafka. These types of things actually can sometimes come in, even Google Sheets, where you have those questions that are coming from the business side and you need to be able to answer it. So it was a real advantage for that. In fact, a couple of the things that we had were the advantages from the point of view of the data analyst is that you can provide a single connection string to them and they don't really need to change. As you add data sources, they're automatically accessible to the BI tools via the catalog. And it ends up looking something like this, where let's pull across, this is dbeaver. So this is just a SQL query tool, nothing special about it. It's open source and available to everybody. And what I've done is I've configured it to go to a Presto backend. So the connection string is just like any other connection string that you can see. This one happens to be running on the Google Cloud. And as you can see, I have multiple different flavors of backends. I have a BigQuery, Elasticsearch, Hive, Kafka, MongoDB, MySQL, quite a few others. And because we only have 15 minutes, I normally actually sometimes write this out, but I left this query up here where I'm actually joining data from a BigQuery backend and a PostgreSQL server, and can run this and provide the data to do whatever it is that I need from this standpoint. So it's pretty handy to be able to do this and explore it later. Right now I left my connection down. So in any case, thinking through the rest of this, the advantage for the business intelligence tool folks is that you can have something like a Tableau, Superset, Power BI. You can drag each of these data sources on the same way that you saw on the tree that I just showed a minute ago. And the same thing is true for the data scientists who suddenly usually have concurrency issues where they're often relying on data science tools like Spark to be able to handle it. And once they get beyond, let's say 3 to 5 people, it starts to gum up. Our worker nodes tend to scale up, especially if you run the version of it that's running on Kubernetes. It can automatically scale as the system gets busy. And then you're able to actually not only have users doing this, but sometimes data science tools are doing things at the rate of machines, which means that your middle tier can handle all of the users' queries going against it, even from an automated system. You can also provide masking and some other data governance. So that becomes really handy as you're trying to do that. And these are some normal data science tools that you often see that we actually have proof of concepts running with just about every single one of these that you can see here. And it's interesting how some people are like, well, yeah, I use these too, but I never use this. And others say, oh yeah, I use this one and don't really use the others. Jupyter and Zeppelin and R, Tensor, I'd say the first 4 are the most common ones that you see. And then, of course, from the point of view of the DBA teams that we were talking about, adding new data sources is pretty easy. It just is that little file that we talked about. And scaling the cluster becomes easy in that if you get, let's say, an end of month type of thing where you're doing a lot of querying, it's really straightforward to do. So I said that we would keep it to 15 minutes. So I kept the presentation really short as to what it was and what it isn't and how it compares. If you'd like to give it a try, you can go to starburstdata.com for downloads. And there's many different methods that you can use. And then on the other end, we have download the free O'Reilly book. So we have a full O'Reilly book that just came out with this. It's very much worth trying. If you go to Starburst Data, you don't have to type in this whole link. You'll find a link to it right there. You can delve into it. And because Starburst is open source, you can give it a shot in your lab without having to do anything else. Naturally, we have an enterprise version that has some other features, but the open source version is very capable, and it's really something worth giving a try in your lab. Finally, thanks to Big Data Boutique for having us here. We're really glad to do this kind of AMA, and now it's AMA time. So feel free to ask questions on the live feed, type it in, and that will get filtered to me through Itamar and through Austin. So we'll go forward with that. So what I'm getting right now through the feed is the key question, how does it compare with data virtualization tools, which is something that we often hear quite a bit of. And those of you who are out there and have done data virtualization are probably familiar with that as a concept where the data isn't actually in this middle tier, sort of like our federated method, but the data gets moved on the spot to the various tools and databases that are actually doing the queries. That usually has a delay because you have to wait for it to move it. The thing that's doing the work, their worker nodes, are actually in a lot of times the back end. We're distinct from that in that we pull things into the architecture that we talked about earlier. And these workers, as I mentioned, scale out, sometimes between 1 or 2 nodes, sometimes 10 or more nodes. Some of the largest clusters that we've had are up to, I think, about 70 or 80 nodes. And that can handle an awful lot of concurrent queries. Or if you're machine-based, it can handle an awful lot of automated dashboards and things like that. So because a lot of this is happening in that interim layer, we actually have some caching that speeds things up. And probably the most interesting thing for those data geeks out there is the fact that it has its own optimization engine that is between multiple data sources. And we often see that type of thing inside of a single DBMS. With ours, it actually does it between multiple data sources and between multiple tables. So, for example, and this is sometimes of interest for the people who really like to see inside of it, when you have a cost-based optimizer that's federated, you end up choosing things based on the cost. That's not the money cost, but the cost in time of CPU, memory, and network needed to execute the query. Of course, time is money. And so what you end up doing is some interesting things like joining the data together in memory when you have a small table, broadcasting that small table to multiple worker nodes so that you can do filtering on the spot and in memory, so that when you have, let's say, 2 very large tables and 1 small table, and it's joining between the 3 of them, your worker nodes are going to be able to handle this much quicker. This is much more efficient than dealing with, for example, something like a data virtualization tool. And there's other advantages to this kind of cost-based optimization that you can do that I'd go into if we had a lot more time, but keeping it at a high level, that's one of the key differences. We also provide some of the features you'd expect to see out of a data virtualization layer that we make very convenient. And that one would have to do with things like data masking, data governance, so that you can deal with, well, this user has access to this table, but not that table. You can even get down to the row level. So another question from the group is the difference between Starburst versus Presto. And Presto is a technology, just a little bit of history on that, has been around since 2012. It was developed actually at Facebook to deal with some of the problems that we talked about at the very, very beginning of the talk, where they were having issues basically granting ETL access and creating data warehouses with a whole lot of disparate data sources, especially dealing with Hadoop style data sources like data lakes and object stores. And they needed to merge data together much more quickly. They also needed a scalable system. So they created it and they open sourced it. And so it's been around for 8 years, which means that it's a fairly mature technology. Interestingly, though, even at the point where it has matured a lot in the world, there's a lot that enterprises need that I really became very familiar with when I was at Abbott Laboratories and would often ask questions of vendors. It's like, well, how do you deal with, let's say, operational needs like management? How do you deal with support? What about some of these more advanced security needs, which very often open source kind of treats it as a secondary thing in order to hit it. We got created as a company, Starburst is, by the way, in order to deal with what enterprises really need to be able to focus on it. So we created connectors that are supported inside of Starburst that are not available in the open source one because they are more enterprise style tools. Certainly Oracle is a key one, Teradata, Snowflake, and some of the other ones that we talked about earlier. Performance, we discussed a little bit in that not only do you have a cost-based optimizer, which the open source one actually handles, but you need to be able to feed that optimizer some real data to be able to work with. And so one of the bigger challenges from a performance standpoint is, sure, it's great when you know that one table is small and the other tables are much bigger and you need to do filtering. But how do you know that it's small in the first place? And so the enterprise connector actually grabs these statistics, the most accurate kinds you can get. And as mentioned before, it actually does things based on that cost. Once you have that, it actually can make some interesting choices for when it's trying to merge data together that you don't normally have in the open source version. And once you do that, the differences between having basically the CBO on compared to off is dramatic. As you can see, the red one right there, and this is for seconds, so this is for time, shorter is better. The shorter it is, the faster your results. Then the blue one is for basically not having those statistics available. The reason why Q20 is so tall is that that is basically a query 20. So we have a whole set of queries. You can see these benchmarks. This is the key. The link that you see at the bottom here, starburstdata.com, Presto benchmarks. A couple other things that are good to see. Connectivity is important, not only in terms of getting the stats, it's important in order to get certain data sources that you wouldn't have in the first place. And the enterprise version of the connectors, we actually found ways to reorganize that and write it in a much more parallelized way. So you can get data from the worker nodes in multiple places. This makes things go much quicker. A couple other items that are worth looking into is the enterprise features like security. Kerberos and LDAP is certainly necessary in enterprises. Global security for fine-grained access control, encryption, masking, auditing, user impersonation, and features like that. From a management standpoint, just a couple items. We make configuration much easier. We've got a graphical interface for it. We can auto scale, which is better than doing it manually or doing it through your own scripting. We can actually make it much easier to do it. High availability options, which is something that was always on my mind as a infrastructure architect. I was always worrying about that, monitoring and deploy anywhere. And of course, support, where we're providing 24/7, 365 support rather than going to the open source community and hoping somebody answers your post in some kind of message board. So that's, I think, all we have time for. And we actually have one more question before I wrap things up. Who does Presto store the metadata of the table? That's an interesting question. It depends. In some cases, when it comes to Hive, we're storing it in the Hive metastore that we can create if you don't have one, and storing that for the Hive statistics. That, of course, needs to be updated on a regular basis. Whereas in your DBMSs, in your databases, they store this on a regular basis for their own cost-based optimizers. And that metadata is available if you query it and are aware of it. So we're often querying the latest statistics as often as possible for the DBMSs, and we run an analysis job against the data stores that you have that are Hive-based in order to do that. The differences are pretty stark, and it's an interesting thing to try in your lab when you have the enterprise version. So you can run a query before and after. That's actually part of how the team ended up with that statistics that you saw earlier. So I'm just going to check and see if there's any other questions that we have here. And of course, yes, there's caching, which is something else coming through, which it does some measure of caching. You can, however, tune what the caching is. I've had questions on, well, how long does it store it for? There are defaults for this. And naturally, there's a configuration file for Presto itself, Starburst Presto itself, which allows you to decide how long to keep it. That caching is a very big deal when you're dealing with Hive. Far, far more of a big deal than the DBMSs, which naturally they do a really good job of caching in memory as much as possible. The Hive metastore is not so intelligent about that. It's not made for that. You basically have a bunch of files out there that can be queried, but you really need to be able to store cache elsewhere. So that's another thing that's very often done during our proof of concepts and that we see is very effective. So let me check the feed one last time and see if there's any other questions. How are we doing on this? Or should we close out? Are we hitting our time limit? Looks like we're good. I see a thumbs up symbol. So again, thanks to Big Data Boutique for having us. And as a reminder, we have one more question, and I'd hate to have that one go unanswered because it's something that comes up very often. And this question is about everyone's favorite topic, security. And the question more generally is, how is that handled? And the answer is, oh my goodness, do we have 6 hours to go through it? Because there's a lot of different features coming in. Let me hit this at a high level and see if that satisfies the group. From a Kerberos standpoint, there are many different backends that may need Kerberos authentication, including from the worker nodes to the data sources. Sometimes it's for the users that are logging into Presto to the LDAP backend. We actually have Kerberos handled on each of these layers. Naturally, you have to enter the keys and everything else that you would expect to be able to do it. And once you tie into LDAP, you naturally have to have the LDAP integration strings and everything else set up properly. This is something that's available in the Enterprise Edition, and it's something that we can work with you on. The documentation is out there. Anybody who's done this kind of work before knows that that's something that you can trip up a lot very often until you get it right. Security, as it should, is something that doesn't work until it does. So it's worth it to set aside a little time to make sure your security team's on handled. Fine-grained access control is particularly useful in that if you need to, for example, because of regulatory reasons, show certain users certain pieces of data, you can have it so fine-grained, you can go either between the database, table, column, and even row level, where you decide based on some kind of criteria that, let's say, some analysts can only see data from the UK, which might be necessary because of GDPR type of regulations. You can do that inside of the system. Data encryption is something that can be done in flight as long as you set it up, and there's different ways to do it at rest, although naturally most of the at-rest data is sitting there waiting for you to query it, so that's there. Data masking, if you're not familiar, is something that allows you to take something like a social security number and push hashtags so that people can see, yeah, that's a different record, but they can't see the entire record. Very handy. Query auditing to know who does what. And user impersonation allows you to push down the user so that in the end data sources, they see that, for example, it's Randy that did the query and not generic Presto user that did it. Couple more questions that are coming through about partitioning on S3 and HDFS and how we would usually do it. That actually depends on the data that's there, since S3 and HDFS data can be kind of anything. Naturally, you need to make it queryable. It's something that's kind of a broader discussion and something that we talk about certainly in the book and other places online. I think that's a discussion best had elsewhere. It does depend on each particular database need that you have, data need that you have. Regarding ETL with Presto, that's something that actually this one's coming from Itamari saying that he gets that question often, how ETL works with Presto. There's a couple answers to that that's kind of interesting from what other companies deal with. So pulling up the image we had from before, we often see this type of thing in terms of a data warehouse that has some of the data that they're very happy with. Sometimes the transforms were doing some necessary changes to the underlying data so that it was more queryable. And then we have those floating data sources out there that they really want to pull under the same hood. So usually what ends up happening is people keep their data warehouses. They just use us to get from, as a company that I just talked to yesterday said, from 70% coverage in their current data warehouse. This was a very, very, very large insurance company in this case. They have just enormous amounts of data. They said the best we could get to is about 70%. The idea is, how do you bridge the rest of that 30% with just a platform? And as mentioned, our architecture is able to do that because once you have this federated layer, you can add the rest of the connections. There are a couple things to be aware of in terms of ETL that is worth mentioning, and that is sometimes the transform is necessary. Or as I like to explain it to the people who are not as in the data space and not as familiar with this, that sometimes, let's say you have sales data where you're selling at one store and they call it an umbrella, and then at another store it's listed as UMBRLA. And in that case, the underlying data is what it is. So to do a query and merge it, sometimes a little bit of transform is necessary. And that's something to be aware of. What Presto will automatically handle for you, which is really nice, is some data sources have a float, others have a double, and others have completely other different terminologies. And naturally, the underlying storage is different. We normalize all of those data sources, data types, so that you don't have to worry about casting. It handles that for you. It's very smooth and easy to use. And what's the recommendation on when to do short-lived ETLs was one final question. And that is exactly what I was talking about before, when the actual transform is not just data typing, but data transforms itself. Sometimes that's necessary and it's nice to do. Here's the great thing. We were talking to one company who's in the middle of doing this kind of transform, a major sweeping project. And among the things that they're dealing with is, well, okay, I have the data here right now, but I'm eventually going to move it over there. With a federated platform, the advantage is you end up just creating a data connection. And one of the data connections could be to your data warehouse or data lake, and another could be to another data source. But let's say you were going to get rid of this SQL server eventually. If you move the data into the data lake so it's cheaper and then stop paying for the licenses for this, you can actually let people query it until it disappears. And then once it's gone into the data lake, people can continue their queries. They just need to be told where it's found. Meanwhile, your platform hasn't changed at all, and you didn't really have to ETL anything. So it's very smooth and easy to do that. Okay, I'm going to do one last check of the the feed. Anything else that we have from my team there, Itamar or Austin? Or should we close out? Looks like we've covered, well, one more thing. Anything else? Good to wrap. Okay. I'm glad that we were able to answer all of your questions. Thanks again to Big Data Boutique for having us. And we hope that you have a chance to give Starburst Presto a try. So you can see the link, starburstdata.com right there. Feel free to grab it. And feel free to reach out to myself, Randy Chertko, or Austin. We're happy to answer questions like this. You can find me and I don't have my email here, but we'll make sure to add it to the notes afterwards. It's randy.chertko@starburstdata.com. You're welcome, Itamar. I've got that. Or reach out to, certainly, and you should, this is probably the easiest thing for all of you to do, reach out to our friends at Big Data, and they can connect you very easily to everything. That's probably the easiest way to do it. You're welcome, Itamar, and thank you for having us. Happy to come back again if you'd like sometime. And we especially love, as you can tell, talking with customers about dealing with these data issues amongst all the choices they have. So really looking forward to working with different people if you want to talk about that. Thanks a lot.
Thank you very much, Randy.